Ravine's here, it's just his mic's not working.
No.
Oh, no, it is.
Hi, Ravine. Can you hear us? Are you there? Trent, are you there?
Yeah, I'm here. I don't know what happened to Ravine.
Well, no, I'm here.
Oh, there he is. Yeah.
Okay, great. So let's start. I'm just going to make it really short, okay?
Yeah.
So the question was this one here. Right, but I'm going to give the solution for B and then we're going to come back to A, all right?
Okay.
So here's the question. So using your algorithm with A, with 100 iterations, use a computation to find an approximate solution to the initial value problem. And it says this one here. So this one is a second order ordinary differential equation. So this is a second order ODE, ordinary differential equation. There's something called partial differential equation, and this is around second year university or third year university level. So you don't have to worry about that. So everything that you're dealing with right now is ordinary differential equation. And this is the y value, and this is the gradient, the first derivative when t equals to 0. So we're still dealing with t. T is the x-axis is replaced by t, and we want to get to here. So what we want to do is come up with the substitution. So y dash equals v. So if we do that, then y double dash is v dash, right? So that's our first equation. You guys still with me?
Yeah.
So that substitution is what they're looking for. They're looking for come up with a pair of first order initial value problems. So that's our first equation, and then you differentiate that and you plug it in here. Then you get v dash minus 3 y dash is v, and then minus 4y equals 0, and then you get the v dash equals to 3v plus 4y, and this is your second equation, okay? That one and that one. So the way I did this is this way. So you got t, and you got your second derivative, and you got your first derivative, and you got your y, all right? So your y derivative, y double dash is the same as v dash, and y dash is the same as v, all right? So that's what I'm going to do. So we start with t equals to 0. And y of 0 is 1, so this initial value is 1. Y dash 0 is negative 26 on 31, like that. And y double dash is based on, so it's very easy. This is our y double dash, isn't it? So that's the equation. So this is equation 2, this is equation 1. So y double dash is simply 3v plus 4y. 3 of this and 4 of that. Okay, so that's a 3. That's v, 3v. This is y here. For y. Understand? So just have to add those two to get this one.
Mm-hmm.
Does that make sense to you?
Yeah. Yeah.
And then what we're gonna do is we're going to do the Euler's formula for y dash. So here you have the y dash, and you're starting from 0, negative 26 on 31. So you're starting from here. So that point will be that point. And then you do the Euler's formula. Go this way, this way, this way. You know what the formula is.
Mhm.
Y equals to y plus the gradient times by the h, right?
Mhm.
This is y1, this is y2. In a similar way, we can apply y dash, because this is, we're dealing with y dash, and the gradient will be, of course, the gradient of that will be this one, so which is going to be the v dash, all right? The v dash. And then you times that by the step. And for this one here, for y, we start obviously from 0, 1, 0, 1, and we're going to do the Euler's formula again. So in this case, y2 is equal to y1 plus gradient times by the h. And in this case, our gradient will be the y dash, which is v. So our next one, so this will be, because we're doing 100 iterations, we're going up to 2. I think the step must be how much? 2 divided by 100 is 0.02, right? So the next one will be 0.02. And how do we find this one here? This one. We take that.
Right.
That value is this value here.
Yeah.
Plus this one here times by 0.02.
Right.
Okay. And how do we do this one here?
That one.
That will be this
Similar
one here.
thing, right? Yeah.
This one
Plus
here plus
a dash.
this one here.
Oh yeah, that one's right. Yeah.
Times by
0.02.
0.02. And then once you've done that, then I think you can. So this one requires that as the gradient. And so once you find those two, then you can add these two to get this one here.
Right.
Because it's simply 3v plus 4y. See that? So let's have a look at on the Excel. So this is the question 2 here. Okay, so the first step is, so this was negative 26 on 31, and this is 1 here, all right? And how do I do this one? So this one is simply the original guy plus the gradient of this one, which is that one there, times by 0.02. And how do I do this one? It'll be that plus the gradient times by 0.02, okay? And then how do I find the double derivative? Is simply the addition of 3 of that and 4 of that, okay?
Yeah, right.
And then you just have to scroll this down. So this one is simply addition of those two. This is made up of those two. This one is made up of those two, and just have to scroll all the way down. Then you get 71 point. So we're looking for the y value when t equals to 2, right?
Yeah.
And you get 71.0884. Okay. Now I just to make sure if this method is correct, I made this into 0.01, and I made the step even finer, and figured out what this gives us. And if you scroll all the way down, you can see that it's a 94.76, and that's pretty close to the answer they said. So this is actually 6.2909. Okay.
Mhm.
Yeah. Does that make sense to you?
Yeah.
Yeah.
So what I'll do later tomorrow, though, I'm going to solve this exactly. This is exactly solvable. And
Right.
I can plug in 2 and see if it's really equal to 96.2909. Your teacher said it's approximately 96.2909.
Correct to 4. Yeah. So as long as it's correct.
Yeah. Anyway, so that's correct to 4. I'm pretty sure your teacher used the exact solution to figure out this value and rounded to the 4 decimal places.
Right.
I'm going to do the same. What we've done here is numerical method, not exact solution, right?
Yeah.
So that's it for B. And the question is, how do we go about write this algorithm? So it's a bit, it's going to be a bit wordy. Well, let's do our best. So you get the idea, right?
Yeah.
So question 2A. So it says write an algorithm. So let's do this. Consider this with a GT, that and that. Okay. Let y dash equals v. Then y double dash equals to v dash. We plug in these 2 equations into the original equation, okay? Then this original equation becomes v dash plus p of t of v, right? Of t.
Mhm.
We don't have to write v of t. So this is y of t, v of t. So you can ignore that, but so this is in terms of t. So this is y double dash of t, p of t, y dash of t, q of t, y of t, g of t. But just gonna skip that for some of them. So this one you just leave it as y, and this is equal to g of t, which rearranges to v dash equals to
G of t minus the other shit.
yeah,
Right?
g of t minus p of t
Okay.
minus q of t y.
Yeah. Yeah. That's
Right.
what I got.
Therefore, the
Wait, do you put it as v?
this one is v. Yeah. Is it
Do you
v?
put-
No, this is
do you
y.
put
Sorry.
PT?
Y. This is y here. Okay.
Like the PT? Like, yeah. With that, is that a v?
Yeah, this one's v here.
Okay. Let's say it's a y.
Huh? What's
I
that?
just put it in terms of y. Yeah.
What's it in terms of y? So this is y dash. Y dash replaces a v. So this y.
Oh yeah. Yes. Okay. All right. Whatever. Yeah.
And y double dash is replaced by v dash. So
Sure.
this is v dash. This one is v.
Yeah.
This one's just y. Okay.
Yeah.
And you move it over. So this is our equation 1. Therefore, the second order ODE can be reduced to a pair of first order ordinary differential equations. Okay. One of them is this, another one is this. Okay. So that's the step. So this is equation 1. You can say this is equation 1. This is equation 2. Okay, next we have to write an algorithm, right?
Mm-hmm.
So we are given these conditions. We are given this.
Mm.
Which can be rewritten as V of T naught equals, hold on. Let me think about this. So this is Y dash V, this one here. So it's kind of hard to, so the procedure is the same. Therefore, we can construct a table as follows. So what needs to happen is you've got your T. You've got your T, and you start with T naught, and you've got your Y double dash of T, which is V dash of T. And you got your Y dash of T, which is V of T. And you've got your Y of T. And this one follows Y dash is V, that's right. The V dash equals 2. So this one follows the V dash equals 2. So they're the same thing, these two. V dash is equal to G of T minus P of T, V of T minus Q of T, and then Y of T, right? With the fact that, so we're given that Y dash of T naught is Y dash, Y naught dash.
Mm-hmm.
So this is a Y naught dash. And they said this is a Y naught. So this is a Y naught. So therefore, this one is going to be, it's going to be a little bit difficult, G of, I'm going to actually do it like this. So this one takes that formula,
Mm-hmm.
this one, but then this one here is going to be G of T naught minus P of T naught, V of T naught minus Q of T naught, and Y of T naught, which is equal to G of T naught minus P of T naught. And we know that V of T naught is Y naught dash, right? Which is Y naught dash minus Q of T naught. And Y of T naught is going to be Y naught. Okay?
Mm-hmm.
You get the idea?
Yeah.
So you have to say we can construct a table like this. And then you have to do a little bit of explanation, okay? As follows. So the first row, where the first row it's actually, you don't have to explain that. Okay, so you can say like the T starts with T naught, and v of t starts. You don't have to mention it. That's too much explanation. So one thing you guys need to know is that even though it looks like it's a lot of unknown stuff, it's actually, they're all known. You can see that this is a known value. They already provide this value, right?
Right.
And they already provide this value to you. So these are constants. This first row here, this is the label, all right? These are the variables, like this one here. As you can see in the Excel sheet, you can see that, that's just a label, right?
Mm-hmm.
And after this first row, should I say second row, you start having these numbers, which are simply just numbers. So there are no variables here. These are all known numbers, even this one here. Because g of t is a known function.
Mm-hmm.
It's a fixed function, so you know that value as well. You already know this value, which is this value here. You know this value. You know this value. All right. So you can maybe say that like g of t, p of t, something like that. P of t, q of t are all known functions, which become a constant when a value is plugged in. I'm just using a little bit of colloquialism here. All right, you get the idea, right?
Yeah.
And also you can say that the initial values for v, so I can say y dash and y, are given by y
0,
y
y0.
dash and y naught, right?
Yeah. Yeah.
Mm-hmm. These two values can be therefore, since y double dash t is expressed in terms of t and y, t and y, y dash and y, we can easily find the y double dash value by using the values in the third and fourth column, like this. Okay, so using those two columns, you find this. The third and fourth column values can be found by using Euler's formula. For the third column, you use, for this one here, you use this one plus that one times by the step, right? So for the third column, you can say that y dash 1, like that, or 2, equals to y dash 1 plus the derivative. So you can say that you have a choice. You can do y double dash t or v dash t. Okay. Y double dash t. So this would be t of 1. Okay. Or maybe you can do like this. So it was 1 because we started with 0. 0 with 0 times by 0.02. Okay, so I'll leave the explanation to you guys from here. I think you guys know what to do, right? The fourth column.
Wait, could you go over what the thing is just one more time?
So you get that, okay? So all you have to say, it's a little bit difficult to describe because there are too many
Right.
things, right? So you have to say this one here can be found by those two. And this one here can be found by that one plus that one times by the step. And this one here can be found by adding this one plus that one, that's the gradient, times by the step.
So when you say the bottom row, is the bottom row like the next increment?
So this is the second row, right? A third
Yeah.
row.
So what would that represent? Would that represent like a different value?
So if I do it here, so you can say maybe we should finish this. So that goes in there. All right.
Right.
And we can call that maybe y double dash naught. You can maybe call that, right?
Yeah, you can. Yeah.
Y double dash naught is given by this whole thing. So this is now T1. T1. So the first thing you have to do is this one. That's the first thing you have to do. So this is step 1. You have to write maybe step 1. Step 1 is find y1 dash, right? Using Euler's formula. So y1 dash equals to y naught dash plus y naught dash dash, this one here,
Yep.
times by the step. Because we're using 100 steps. You have to justify y 0.02.
Right.
Next, step 2. So because it's an algorithm, you have to write it like this. Find y1, y1, this one. This is y1. This is a y1 dash, right? So y1 using Euler's formula again. Like that one there, like this, okay? And you can do it by using y1 equals to y naught. That's 1 plus the gradient times by 0.02, right? So you find these two first. So this is step 1.
So with the justification for the h value, would that just be from using Excel and being like, oh wait, this is
you just have to say step size is 2 minus 0, because we need to go from 0 to 2 and divide by 100 steps. So the formula is h is simply b minus a over n. All right, that's the formula. That's the number of steps, and this is the interval. So we're going from 0 to like 2.
Right, okay.
Yeah.
Yeah.
So that's why this is 0.02, okay?
Yeah, thank you.
So using Euler's formula, you go there, you do that, and then the step 3 would be to find this one, find y1 double dash by using y1 dash and y1, okay? Using this formula, you know that y1 dash dash equals to g of t1, okay, minus p of t1, and then this one would be replaced by y1 dash, minus q of t1, and then y1, okay? Does that make sense to you?
Yeah. With the like the interval, so you know how it says we need to go to 2? You know how it says we need to go from 0 to 2? Like that?
Yep.
Where does it say that in the assignment? Like,
Oh, because we're starting from 0,
yeah.
and we're trying to approximate. We're given these initial values, and we need to approximate this value at t equals to 2.
Oh, okay. Oh, yeah, yeah. Sorry.
Okay. So
Wait, it's different in my one though. In my assignment sheet, it says it doesn't say anything about t equals 2.
yeah, so your teacher made correction to that.
Oh, okay.
So there's an updated version. This is the updated version that Vishal sent to me. Yeah. So I would say step 0 is the step size. Choose the step size to be 0.02. And also the first row, if you call this one the first row, okay, and this is the second row. Let's get rid of that label because it's confusing. Step 0 would be to find. We're given would be to find the y0 double dash. This one here, which is given by g of t0 minus p of t0. And then y0 dash minus q of t0 and a y0. Okay, so that's given because of this second equation here. That's all because of the second equation. Okay, so first step, the 0 step is you find this value. These two are given. Understand? So these two are given. And you find this value using those two. And then you find this one. That's the step 1. Using these two. You find this one using these two. And then you find this one. That's the step 3. And then step 4 will be repeat.
Yeah, repeat for the next increment.
Repeat step 1, 2, 3. You don't have to repeat step 0. Repeat step 1, 2, 3 with n equals to 2. Yeah, it's 1, 1, 1. So it must be n equals to 2. 2. Because there are 100 steps, like 101, I guess. Hold on. So this would be 0. This would be 0.02. So if you go down to t what, then it'll be 2. T2 would be 0.04, right? So it'll be 100, I guess. Yeah. T. For t equals to t 2, which is 0.04, to t equals to t 100, which is 100 steps. That's right, which is 2.00. That's right. So yeah, that's it really. That's the algorithm. Okay. So let's call it a day here. So I'll paste. I'll save this one.
And where do you put the recordings to?
I'll put it on YouTube as private video. I haven't sent the I haven't uploaded any of the videos yet, but I'll do it tonight and send it to you guys.
Okay, awesome.
Thank you.
Okay.
Where does the image go as well?
Yeah, I'll send it to you. I'm just I haven't shared anything because I don't know if the other girl wants to do it. If she doesn't want to do it, she really has to make sure. Otherwise, we'll have to create a separate group for it. Okay.
Yeah, I don't think she'll. We can kick her out if she. I don't think she wants to.
Yeah. All right. Cool. I'll kick her out then.
All right.
Okay. Yeah. All right. Cool.
So thank you.
See you next time. Yep.
Oh, thank you.